Energy. It's the ultimate shapeshifter. Seriously, it's completely invisible, yet it dictates literally every single action in our modern world. Think about it for a second. A simple flick of a light switch relies on ancient plants buried deep underground millions of years ago, or, raised from the sun traveling almost 100 million miles just to reach us. These raw, untamed forces of nature somehow transform into the invisible current that's lighting up the very screen you're looking at right now. So, welcome to today's Explainer. We're going to trace that incredible journey and demystify exactly how we take raw power from the earth and the sky and morph it into the electricity that powers our everyday lives. Here's a quick roadmap for today. We'll start with the energy shapeshifter, move into fossil fuels and combustion, then check out hydroelectric power and solar panels. And finally, we'll wrap up with how all of this powers our real world.
All right, Section 1, the energy shapeshifter.
To truly understand our power grid, we have to realize a fundamental truth. We don't just make energy out of thin air, we transform it. Energy transformation is really the whole game here. It's all about converting different primary sources into electrical energy. Today, we're going to track this exact invisible shape-shifting sequence. We'll follow the energy from its starting point through some really cool color-coded shifts all the way to the final output. We basically take energy in one raw form and we coax it, push it, and pull it until it becomes the form we actually consume. Let's dive into Section 2, fossil fuels and combustion. Let's step into a traditional coal plant. For over a century, this has absolutely been the backbone of human industry. But how exactly does a cold black rock turn into a glowing light bulb? Well, it starts with combustion. Simply put, combustion is the process of burning chemical energy, like coal, oil, or natural gas, to create heat. Think of fossil fuels as massive storage batteries of ancient sunlight, locked tightly away in chemical bonds. To unlock that stored power, we have to introduce fire. We burn it. That combustion process is the great releaser, completely transforming dormant chemical potential into raging active heat. Let's follow that transformation step by step. It begins with the green chemical energy locked right there in the coal. Combustion forces that to burst into glowing orange thermal energy. That intense heat boils water into high-pressure steam, which then slams into heavy machinery, creating mechanical energy. Finally, those spinning turbines drive a generator, outputting our final pure blue electrical energy. So green chemical to orange thermal to spinning mechanical and finally to blue electrical. It is a massive, complex chain reaction just to get to that final output.
Okay, Section 3, harnessing hydroelectric power.
So fossil fuels require fire, right? But what if we just used gravity and water? Picture the massive, towering walls of a hydroelectric dam. Water resting high up behind that wall possesses gravitational potential energy. It's just waiting silently, storing immense power based purely on its height. But the second those gates open, gravity takes over. That stored potential instantly and violently transforms into mechanical kinetic energy as the water rushes downward. Tracing this second journey, we start with the gravitational potential energy of that high water. As it falls, it transforms entirely into the mechanical kinetic energy of a rushing river. That sheer physical force directly strikes the turbine blades, triggering the generator action. And just like in the coal plant, that spinning generator outputs our glowing blue electrical energy. Notice what happened here. We bypassed the orange thermal heat entirely. We just used gravity's pull to create the mechanical motion we needed. Pretty brilliant. Moving on to Section 4, solar panels and the photovoltaic effect. Now, let's look at a sprawling solar panel array. This transformation is arguably the most elegant of them all thanks to the photovoltaic effect. This is the direct conversion of light energy into electrical energy. And I really want you to note that word, direct. In the fossil fuel plant, we had to boil water to spin a turbine. In the hydroelectric dam, we dropped water to spin a turbine. But the photovoltaic effect, it requires zero moving parts, no spinning turbines, no mechanical middlemen whatsoever. It is a leap straight from raw sunlight to electricity right at the atomic level. Just look at how simplified this path is. Raw light energy straight from the sun hits the panel's surface. Photovoltaic conversion silently takes place within the specialized materials, knocking electrons loose, and immediately we have our blue electrical energy. Light straight to electricity. It's an incredibly direct shape-shifting trick that completely skips the heavy, noisy mechanical machinery we saw in those first two examples. Finally, Section 5, powering our real world. We've tracked energy from green chemicals, rushing water, and silent sunlight, all the way to those final blue arrows of electrical output. But why do we go through all this trouble?
Well, because this is where the science hits reality. That blue electrical energy is exactly what is pumping through your walls right now. It's the refrigerator quietly keeping your food safe, the lights banishing the dark in your living room, and, let's be honest, probably most importantly for a lot of us, it's the current flowing into your phone charger so you don't miss a single notification. We harness these massive global forces just to make modern human survival and comfort possible.
Which brings us to a really critical thought to leave you with today. As our homes and our technologies demand more and more of that blue electrical energy every single year, which shape-shifting journey is going to power your tomorrow? Will we continue relying on the combustion of ancient green chemical energy? Are we going to build more massive dams to capture gravitational potential? Or will the direct, silent photovoltaic conversion of sunlight take over the grid? The science of energy transformation is crystal clear, but how we choose to apply it next, that is the greatest challenge of our time. Definitely something to chew on the next time you flip a light switch. Thanks for joining me on this explainer, and keep exploring the incredible world around you.